So sometimes, just like when we're just doing adding and subtracting of fractions, we have to factor our denominators. But the thing that we have to do is we have to check at the end, as we've mentioned before, that our solutions that we arrive at don't end up extraneous, meaning that they don't result in division by zero. So to get started on this first one, we need to factor this denominator. The other two, there's nothing that we can do with those, but we do need to factor this one. So I'm going to break it up into two sets of parentheses. And so I know it's going to be x as the first piece. I know I need one of each since I'm multiplying to make a -3. And then the only way I can multiply to make 3 is with 3 and 1. And I need the 3 to be positive and the 1 to be negative, so I end up with that positive 2x in the middle. Then the other two fractions, I'm just going to leave them untouched since there's no factoring or anything like that that can be done. And so now when I look at the landscape of all these denominators, I can see that my common denominator is going to include both of the factors x plus 3 and x minus 1. So I'm going to multiply everything in the problem by x plus 3 times x minus 1 over 1. So I'm setting up a giant distributive property question here. So I've got x plus 3 times x minus 1 over 1 times 12 over x plus 3 times x minus 1. Then I've got my equal sign. I've got x plus 3 times x minus 1 over 1 times 3 over x minus 1. So I'm just multiplying that common denominator times the second fraction. And then one more time, x plus 3 times x minus 1 over 1 times the third fraction, so 2 over x plus 3. And so now I can perform these multiplications one at a time, doing any cross-canceling that I can. And when I'm done, I should end up with no fractions in any denominators. So looking at the first piece here, everything cancels out, x plus 3 and x minus 1, so we're just left with 12. In the second piece here, when I multiply, I can see the x minus 1s are going to go, but I'm going to be left with x plus 3 times the 3 that I see here. And then plus, this time the x plus 3s can cancel out, but I still have the x minus 1 times the 2. So x minus 1 times 2. So we've got a much more ordinary equation to solve now. So I'm going to distribute and then eventually gather some like terms. So I've got 12 equals, if I distribute here, I get 3x plus 9. And then if I distribute here, I get plus 2x and then a minus 2. So I'm going to gather my like terms on this right-hand side. 3x and 2x gives me 5x. And then 9 and minus 2 gives me plus 7. So then to close things out, if I scroll down a little bit to give us some room, I'm going to subtract 7 from both sides. So I get 5 equals 5x. And so the last step is to divide both sides by 5. And so we end up with x equals 1 as our answer. But if we go back to the original problem, we can see that x equaling 1 is going to result in division by 0 here in this fraction, and it actually would result in division by 0 in the first fraction as well, since when we factored that denominator, we had x minus 1. So as a result, I have to throw this answer away, and since that was my only answer that I had to this problem, I'm going to just say that this problem has no solution. So it's really important at the end of the problem that we go back and check to see if that answer works in the equation, doesn't result in division by 0 in any denominator, otherwise we have to throw it out like we did here. So for our second and final example, I'm going to clear a whole bunch of space here and then get us scrolled up a little bit. So again, just like on the previous question, we're going to have to factor one of our denominators to see how it overlaps with the others. And so we can leave that first fraction as is, 6 over x minus 3 equals 8x squared over, now hopefully we recognize that x squared minus 9 is a difference of squares, so I'm going to be able to factor that into x plus 3 times x minus 3, And then we have that second fraction on the right-hand side, 4x over x plus 3. So now as we look at all of our denominators, we can see that the two factors that are present in one or more of the denominators is x plus 3 and x minus 3. So I'm going to multiply all of these by x plus 3 times x minus 3 over 1 to guarantee that I can get rid of all of my denominators and end up with a relatively ordinary equation to solve. So giant distributive property set up here. So we've got x plus 3 times x minus 3 over 1 times 6 over x minus 3. And then that's equal to x plus 3 times x minus 3 over 1 times this fraction here, 8x squared over x plus 3 times x minus 3. And then finally, I'm going to take that same common denominator, x plus 3 times x minus 3 over 1 times our last fraction, so 4x over x plus 3. So now we're ready to start doing our reducing, simplifying to get rid of all of these denominators. So over here, I can see I've got x minus 3 that cancels out, so I still have x plus 3 times 6. And then that's equal to, in the second fraction here, so we're going to be able to cross cancel out everything. So the only thing that's left is 8x squared. And then on the last part here, we've got x plus 3 that can cancel out. And then we just have to be careful that this is subtraction here. So I need a minus, and then it's x minus 3 times 4x. So I have some distributive property that we need to do. And then we can see that we have an x squared in the problem, so we're going to have to gather everything on one side and solve by factoring. But on this right-hand side, or left-hand side I should say, if I distribute, I get 6x plus 18. And then I still have this 8x squared. And then I have to distribute this 4x. But we have to remember that there's also this minus here. So it almost might be better for us to think of this as us distributing a negative 4x into the parentheses here. So maybe make this plus and then this negative. So we're going to distribute a negative 4x because of that subtraction symbol. And so we've got negative 4x times x is negative 4x squared. And then negative 4x times negative 3 gives us positive 12x. And so now I'm going to gather my like terms, and I'm going to pile up everything on one side. So I'm going to go ahead and move this 6x over. I'm going to move the 18 over as well. So now that gives me 0 over here on that left-hand side. And then on the right, I'm going to gather my like terms. 8x squared minus 4x squared gives me 4x squared. 12x minus 6x is positive 6x. And then I have a minus 18 to close things out. So I can see that I can divide everything by 2. So that'll make my factoring life a little bit better. So I'm going to scroll down. And so if I divide everything by 2, I get 2x squared plus 3x and then minus 9. And so now we have to set out to factor this expression. So I know it's going to be 2 sets of parentheses. I know it's going to have to be 2x and x. And if we want, we can use our box technique on this problem that we used earlier in the year. We can also just kind of go with a trial and error approach since we don't have too many ways that we can multiply to make that 9. And so I know I need a positive and a negative. I know I need the positives to win out. So I'm going to put the positive away from the 2x, so I'm multiplying the larger x there. And if I break it up as 3 and 3, that's going to work for us. Negative 3 times the positive 3 makes the negative 9 that we need. And then 2x times 3 gives us 6x. And then negative 3 times x gives us negative 3x, which combine to make the 3x in the middle. So we can take these two factors, 2x minus 3 and x plus 3, and set them both equal to 0, and then solve these little mini equations. So if I add 3 to both sides, I get 2x equals 3. If I divide by 2, I get x equals 3 halves as one of my answers. And then over here, if I subtract 3 from both sides, I get x equals -3 as my other answer. But before I just accept both of those, I need to go back to my original equation and make sure that I don't result in division by 0 with that -3 answer. And indeed, we do. If I plug -3 in for x right there, I'm going to get a 0 in the denominator. Same thing would be true in this one as well, but just 1 is bad enough. So I have to throw this answer away, and so my only answer that I'm going to keep is this 3/2.